Hey guys, so this next lesson is on graphing polynomials from standard form. So far, we have been graphing them from factored form. So standard form, remember, looks like this, where it goes highest degree to lowest degree. We need to get it to factored form so that way we can get the zeros and the multiplicity and figure out how to do the graph. So yesterday, hopefully you had some practice with factoring, and now today we're going to get into the actual graphing. So the first thing that you always want to do when you are factoring is you want to look for a GCF, greatest common factor. A lot of the ones we're going to do in this section have a GCF. So you want to look at all three terms and think about if they all have something that will divide evenly into each of them. So in this case, there's no number that goes into all of them because this is a 1 here, and while 8 does go into those two, it doesn't go into 1. So they have an x in common, so we're going to take out an x. Once you take out the x, you put it outside a set of parentheses, and you ask yourself, what do I multiply x by to get x to the third? Well, we need 2 more x's. What do we multiply x by to get 8x squared? We need an 8 and an x, and then lastly, we'll have a 16. Once you factor out the GCF, then you will have something left over, in this case, a trinomial, which can be factored further. This is a trinomial where a is 1. So that's when you think about numbers that multiply to 16 and add to 6. So look at your factor chart, look at the multiples of 16, not multiples, factors of 16, and see which pair would add to positive 8. It's going to be positive 4 and positive 4, because 4 plus 4 is 8, 4 times 4 is 16. Now, anytime you have a factor that repeats itself like this, remember that's being multiplied by itself. So for the sake of factored form and graphing and trying to figure out multiplicity, we're going to write it as that, x plus 4 squared. You only do that if it's the same exact factor twice. So that's your factored form. We can write that over here. And now we can fill out everything else so we can graph. The degree, there's a 1 here and 2, so that's 3. Another way you can get the degree is if you look back at the standard form, the highest degree is your overall degree of your function. Sign of the leading coefficient is positive. 0 is multiplicity. This one is going to be 0, multiplicity 1, and then we're going to have negative 4, multiplicity 2. Remember, when you're graphing, you first want to put your zeros in. So 0, 1, 2, 3, 4, negative 4. Then you do your end behavior arrow. So you want to look at that end behavior chart. This is an odd number, so it's odd positive. Odd positive, the right side goes up, the left side goes down. When you are graphing, you want to work your way to the middle from the ends. There's only 2 here, so it's pretty easy. 0 is multiplicity 1, so I'm going to go straight through 0. There we go. Okay, so that goes through 0. And then at negative 4, it hits it and bounces back. So we're going to hit negative 4, bounce back. And so now we have this. Something like that. Okay, so there's our first one. Okay, again, this next one, we're just going to factor and then graph, just like how we've been graphing. So we're going to look for a GCF. If you look at each term, they each have at least 2 x's. So x squared is going to be my GCF. Since the leading coefficient is negative, you want to take out a negative GCF. So it's negative x squared that we're going to put on the outside. So then you have to think about, what do I multiply negative x squared by to get to negative x to the 4th? It's going to be x squared. Then the middle one is going to be negative 3x. And the last one is going to be negative 10. Now remember, if you were to distribute this to all 3 of these, you would get back to the original. So that's how you can tell if you're doing it right or wrong. Now right here, we have a trinomial where a is 1. So we want 2 numbers that multiply to negative 10 and add to negative 3. So if you look at your factor chart, it ends up being negative 5 and positive 2. Remember, when you have a positive and a negative, the higher one, so 5, takes the sign of the middle term. So whatever the middle term sign is, that's what the bigger factor is going to be. Okay, we also need this negative x squared still out in the front, and so that's our factored form. So I'm going to write that right here. Negative x squared x minus 5, x plus 2. All right, so the degree, we can either look right here and see that it's 4, or we can add 2, 3, 4, either way. So that's even. It does have a negative leading coefficient. 0 is in multiplicity, so we have 0 multiplicity 2, we have 5 multiplicity 1, and negative 2 multiplicity 1. Okay, so let's plot our zeros. So we have 0. We have 1, 2, 3, 4, 5. We have negative 2. Okay, even and negative is they both point down. Okay, negative 2 and 5 are both multiplicity 1, so I can go straight through those. And then 0 is multiplicity 2, so this has to come back down here and then connect here. I'm gonna fix this a little bit. Oops, I did not mean to erase all of that. Oh boy, okay, that's all right. There we go, something like that. Okay, so there's that one. Okay, this next one, again, look for a GCF. Notice that these all have an x in common, so I'm going to take out an x. And then we have x squared minus 2x minus 3. And now this is a trinomial that we need to factor. So we want numbers that multiply to negative 3 and add to negative 2. So it's going to be negative 3 and positive 1, because negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So that's our factored form. Our degree is 3, which is odd. The sign of leading coefficient is positive. Zeros in multiplicity, we have 0 multiplicity 1, 3 multiplicity 1, negative 1 multiplicity 1. Okay, so let's plot them. We have 0, 3, oops, we only need negative 1, just kidding. Okay, odd positive, the right side is up and the left side is down. These are all multiplicity 1, so it makes it pretty easy. We can just go straight through all of them. And there you go. There's example 3. Here's the next one. So this is one where it's 4 terms. So actually, let me back up. You first, obviously, always want to look for a GCF. There is no GCF here. Notice, though, that this is 4 terms. So this is the type of factoring that's factored by grouping. So remember, for this, you put parentheses around the first 2 and the last 2. You take out the GCF of each grouping. So x to the third and 3x squared has a GCF of x squared. So then we have x plus 3. Negative 4x and negative 12 has a GCF of negative 4. So then it's x plus 3. Then you take the repeated one, and that's one of your answers, or one of your binomials. And then you take the GCFs that you took out, and that's your other binomial. So you may be able to notice just by looking at this that this one looks a little funky. We don't usually have things like that in our factored form. So this is what we learned today, or yeah, this is what we learned recently, not today, which is a difference of squares. So this is a type of factoring that I showed you guys recently. We didn't learn it earlier in the year, but it does come up every now and then in this unit, so I figured I'd show you. These are both perfect squares. Remember, perfect square is something that if you multiply by itself, it's something that has a whole number that you can multiply by itself to get that number. So the square root of, since the square root of 4 is a whole number, it's 2, because 2 times 2 is 4, then that makes 4 a perfect square. Sorry if I messed that up. But anyway, so what you do is it ends up being 2 binomials. You put the square root of the first term in the first spot, which is x and x, because x times x is x squared. And then the square root of 4 is 2. So that goes there and there. And then it's always a plus and a minus. I will remind you of difference of squares when they come up. And so that's it. Now that looks more like our typical factored form. So we have x plus 3, x plus 2, x minus 2. Our degree is going to be 3 again. 1, 2, 3. Sign of leading coefficient positive. 0's multiplicity, we have -3 multiplicity 1, -2 multiplicity 1, and 2 multiplicity 1. Okay, so let's plot them. -3, -2, and 2. Odd, positive, the right side goes up, the left side goes down, and again, these are all multiplicity 1, so that makes it a little bit easier. Straight through for all of them. And there's example 4. That one's a little trickier. And then here's our last one, example 5. So we want to look for a GCF. Notice that these all have at least 3 x's. So it's going to be x to the third, and then it's negative. So we're going to take out -x to the third. -x to the third times x squared would give us -x to the fifth. -x to the third times -7x would give us 7x to the fourth, because a negative times a negative is a positive. -x to the third times +12 would give you -12x to the third. So you're taking out x to the third from all of them, a -x to the third. So now this is a trinomial. So now it's a trinomial where a is 1. So now we can factor. We want to think about numbers that multiply to -12 and add to multiply to +12, add to -7. It's going to be -3 and -4, because that makes +12 if you multiply them, -7 if you add them. So now that's our factored form, and we can graph. Okay, the degree here is going to be 5, which is odd, and then negative leading coefficient. Our zeros, we have 0, which is multiplicity 3, 3 multiplicity 1, and 4 multiplicity 1. Okay, so let's plot our zeros. We have 0, 3, and 4. It's odd negative, so the left side is up and the right side is down. So we're going to go multiplicity 1 through 4. 0, multiplicity 3 for 0, so this is going to kind of like, whoops. That's not what I want to do. Let's just move to this. That was weird. Okay, let's try this again. Okay, so it's going to go like down and over and up, and then up and over, and then go through 3 and connect, something like that. Just as long as you make sure that right here it doesn't go straight through, make sure it curves a little bit. And there's example 5. So the trickiest part is obviously the factoring part. Everything else we've been doing, you guys are pretty good at that. So that's it. Let me know if you have any questions, and have a great day.